All right, welcome back everybody to our Calculus 3 class notes. We're on page, why do I always forget the page? We're on page 79 in section 14.8 on Lagrange multipliers, example 72. So let's find the maximum and minimum values of f of xy equals 3x plus 4y on the circle x squared plus y squared equals 1. So that means we want to use Lagrange multipliers with f of xy equals 3x plus 4y and g of xy equals x squared plus y squared minus 1 equals 0. We need g to be equal to 0. So you take the gradient of f, get 3, 4. That is equal to lambda times the gradient of g, so lambda times 2x, 2y. So what do we have? We have 3 equals lambda times 2x. In other words, x equals 3 over 2 lambda. And we have 4 equals lambda times 2y. In other words, y equals 4 over 2 lambda, which is 2 over lambda. So if I plug those into my constraint, g equals 0, I'll be able to solve for lambda. So when I get that, I get 3 over 2 lambda squared plus 2 over lambda squared is 9 over 4 lambda squared plus 4 over lambda squared equals 1. So common denominator is 4 lambda squared, so this is 16 over 4 lambda squared, so I get 9 plus 16 equals 4 lambda squared, which is 25. 4 equals 4 lambda squared, so 25 over 4 equals lambda squared, which means lambda equals plus or minus 5 halves. So once I know that lambda is plus or minus 5 halves for each of those, I plug it in to solve for x and y. So for lambda equal to plus or minus 5 halves, that means x is equal to plus or minus 3/5, and y is equal to plus or minus 4/5. So f of x and y, which is 3x plus 4y, has extreme values at these values of x and y on the circle x squared plus y squared equals 1. Plug them each into f of x, y, and you can see that the maximum value is 5, and the minimum value is minus 5.